they can hear you, young man, in the background, not allowed to mention any names. But you always thought this is the free lunch theorem.
What?
You thought there was no such thing as a free lunch, but this is the binomial theorem. So if you binomial, and it's the free lunch. I made that one up. Okay. Thank you. So, am I recording? I'm recording, right? I have to make sure that. Oh, good. Okay. So the x plus y raised to the n. You're going to say what? Look at this, like that guy. It's the sum from r equals 0 to n of this. Ooh, n r x. Whoops, I messed up. X raised to the n minus r, y raised to the r. There it is. Okay, go ahead. You can start your homework now. Okay. So what does the binomial theorem mean? Okay, this NCR is a combination. NCR. Okay, NCR is equal to n factorial over n minus r factorial. Have any of you ever done this before? Okay, that's called a combination. It's an arrangement. These numbers you can find on your calculator. You can do them by hand. You're going to have to do a couple by hand. Show me that you know how to do them by hand, but I'll show you how to do it with a calculator. Okay. But NCR is equal to this. Another way you will see it is like n goes here and r goes here, okay? And so this means these two things are the same. And so n, this is red, n items taken r at a time or something like that. So if you see 5C3, that means 5 combination 3. Means you have 5 objects and you're going to pick 3 of them. We're not really worried about that as far as probability goes. But if I did have 5C3, I'll get back to this in a minute, and I'll do some more of these in a second. That means 5 factorial over n minus r factorial, which is 2 factorial, 3 factorial. Okay? And this means, so the way you solve this algebraically is you go 5 times 4 times 3 factorial, right? And then you would divide by 3 factorial and 2 factorial. What happens to the 3 factorials? Those go away. And you get 5 times 4 divided by 2 factorial, which is 10. Okay? 5 combination. That's right, 5 combination 3. You can think of it too, you have 5 things to choose from. How many ways are there to pick those 5 things for 2 spots? Okay? It's kind of like this. It's 5. Like here's your 2 spots. You have 5 spots for the first place. Then since you've already picked one of those things, you have 4 things left. How many ways could I arrange 5 and 4? How many different ways could I arrange 5 and 4? 2, right? That's why you divide by the number of arrangements of these things, and that gives you 10. Just know how to do it for now, okay? Another way you can get these things, this is really cool. Remember Pascal's triangle? You did that coloring thing on it. 1, 3, 3, and I'll show you how to do this on your calculator too. 1, 4, 6, 4, 1. You guys understand where I'm getting all these numbers from? Yes. 1, 5, what goes here? 10, 10, 5. I'm just adding together the 2 things above it, right? So 1 plus 2 is equal to 3, 2 plus 1 is equal to 3, 3 plus 3 is equal to 6. That's where 3 plus 3 is equal to 6, 4 plus 6 equals 10, 6 plus 4. The next row would look like what? 1, 6, 15, 20, 15, 6, 1. Why am I talking about Pascal's triangle here? Because combinations can be found in Pascal's triangle. For instance, 5 combination 3, 5C3. Another way to do it is to go down to the 5th row of Pascal's triangle. So this is row 0. The first row is actually called row 0. And this is row 1. And this is row 2. And this is row 3. And this is row 4. And this is row 5 right here, right? Row 5? Yeah. And then I'm going to go to the 3rd column. So if I'm in the 5th row and I'm starting on this side, this is the 0th column. 0th column, I guess. And this is the 1st column. So 0th column, 1st column, 2nd column, 3rd column. There you go. This is 5, row 5, column 3. Look, 5 2's 3, 5 combination 3. Isn't that cool? So those numbers. So this would be. So this number would be 5 combination 4. This would be 5 combination 5. This would be 6. 15 is 6 combination 0, 1, 2, right? This is 6 C2. This is 6 C3. This is 6 C4. This is 6 C5. This is 6 C6, etc. So all of those combinations can be found using Pascal's triangle, which is pretty cool, right? Yeah? No? Maybe. So what does this ugly thing here mean? Okay? Base, partial. So some of you know, you did binomial theorem last year, no? Yes?
Yeah.
Okay. So what, I doubt you saw it in this form. But what it means is it's just a way to do a high degree expansion rather than so if you want to do this to the 6th power, you don't want to multiply x plus y times x plus y times x plus y times x plus y, right? You want to use a formula. So this formula says that the first term would be n combination 0 x raised to the n power. Okay? You start with 0 down here, and then it'd be r raised to the 0 power. Because NCR x to the n minus r, and this number here always agrees with that number here. That's the first term. I'll show you what
Shouldn't
the
it
next.
be y to the 0?
Oh yeah, sorry. Yeah, you're right. Thank you. Y to the 0. The next term is going to look like 6n combination 1. Okay. This one goes down by 1, so this becomes n minus 1. This one becomes 1, right? This number here always agrees with that number there. Yeah? Okay?
Yeah.
Plus, what would the next term look like?
2's.
NC2 x to the n minus 2 y to the 2. And you keep going like that until you get to the last term, which is NCN x to the 0 y to the n. Okay? So these numbers this starts at 0 and ends at n. This starts at n and ends at 0. Okay? Yeah? Oh. So, and then the other thing you got to know is that NC0, no matter what is there, that's equal to 1. And NCN is also equal to 1. And then 1 lower, NCN minus 1, that's equal to n. So those are just some useful things to know rather than put this in your calculator every time. These are useful definitions to know. All right, so we're going to do one now using either the combinations or Pascal's triangle. So say I want to do x plus 2 raised to the 4th. You ready? Wait. I'm still recording. Ready? Set?
Ready.
And
Begin.
begin. So say I want to do x plus 2 raised to the 4th power. I'm going to start with 4 combination what?
C.
What goes down here? What always starts here? 0. Okay. Then I'm going to do x raised to, this is your highest degree x term, so what goes up here? 4. 2 raised to the 0. Right? So this is like, this is x, this is considered y, right? So it's x and y. And if this were like, we'll get to some other. Okay, then it's going to be, then it's going to go 4 combination what? 1 x to the, this goes down by 1. Down by that, and this goes up there, right?
What is this C again?
That, so the C gives you the, it's the combination. You can find that number, that's a number. So this number 4 combination 0, 4 combination 1, that's a number which I'll show you how to get it on your calculator too, but it's a combination.
No.
It's this, okay? That's what C is. It's that number, okay? Okay? Fantastic.
No.
Okay? So what's the next term going to look like?
4C.
4C 2x to the 2 to the 2 plus 4C 3 x to the 1, right? 2 to the 3 plus 4C4, right? 4C4 x to the, I'm getting squished here. Oh, I could go this way. X to the 0, 2 to the 4. Yes?
Yeah.
Yes, Avery.
Do we have to write it with the C, or can we just do N over R? Because they mean the same thing, right?
Well, could you write it like this?
Yeah.
4, 0, like that? What did I just do? Not over.
Not
It's
over.
just- It's like, yeah, that's fine. Okay? What did I just do? What? So now we're going to compute these. What's n combination anything 0? 1. What's 2 to the 0? What's anything to the 0? 1, right? So this first term just becomes x to the 4th power, right? Yes?
Yes.
4 combination 1 is this, that would be the second, it's just 4, okay? 4 combination 1 is just 4, x to the 3 times 2, right?
2x.
Right? If I didn't remember what 4 combination 1 is, you could do it like this. 4 factorial over n minus r factorial, so at 3 factorial, r factorial, 1 factorial. So that's equal to 4 times 3 factorial divided by 3 factorial, which is 4.
Where
See?
y is 3x.
X cubed, sorry, x cubed, sorry, plus 4 combination 2. 4 combination 2, 4 times 3 divided by 2, I think that's 6, right? 4 combination 2, I believe that's, is it 6? 4 times 3 divided by 2 is 6, yep, so that's 6. And I'll show you, you can either get these from Pascal's triangle, or you can, I'll show you in a second.
How do you solve it?
Where you get them on your calculator, 4, right? Plus, I'm going to move this, so I'm going to erase this because it's in the way. Okay? Plus, the 4 combination 3 is the same as 4 combination 2. No, is it? No, 4 combination 3 is 4 as well. So that's plus 4 x to the 1 power. And I'm writing these all out. I know x to the 1 is just x. Okay, plus 4 combination 4. What's 4 combination 4? 1. What's anything raised to 0? 1. What? 2 to the 4th, right? So that just becomes 2 to the 4th. Yeah? And now I simplify. So I write this as x to the 4th. 4 times 2 is 8x cubed. 4 times 6 is 24x squared. 4 times 8 is 32x. 2 to the 4th is 16. And there you go. Isn't that cool?
Yeah.
I love it. I love it. Oh, how do you do that on your calculator? Watch. On a test, you have, so you would, if I want to do 4 combination, whoa, sorry. Whoa. ERT team to, no, you're trying to trick me. You go 4, math, PRB, because combinations come up all the time with probability. See this? NPR, that's a permutation. NCR is a combination. So you have to do 4, NCR 2, and then you hit enter, and then you get 6. So, got it?
How do you solve
Do that
that?
again?
Do it again. 4, math,
factorial over 2 factorial plus 2
PRB, combination 3, or combination 2. Watch the video if you missed that. Okay, I gotta move on. Hashtag what? What? Okay, so now, what about something like this, which gets a little more trickier? Say I have more trickier, okay? 2x plus 3. Let's do minus 3. Joke of the day? I don't have time. I already told you a joke of the day in my...
Well,
that wasn't the joke of the day, that was the joke of the
Hey,
hour.
you be quiet.
That was horrible.
Okay. I'll tell you a funny story, okay? You want to hear a funny story?
Yeah.
I have to stop. Move it up. So if I saw something like this, okay? So you consider this to be like, this whole thing to be like X and this whole thing to be like Y, okay? So you have to be careful with something like this because it's going to start off with 5 combination 0, 2x, the whole thing raised to the 5th power, negative 3 raised to the 0 power, right? Okay, plus, always put a plus sign because this negative sign gets taken care of here, you see? So the next term is going to be what? 5 combination 1, 2x raised to the 4th power, negative 3 raised to the 1 power, plus dot, 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 dot. I'm not going to do them all, okay, because I don't have time. But 5 combination 0 is just 1. 2x to the 5th, you have to raise 2 to the 5th and x to the 5th. So that becomes 32x to the 5th, negative 3 to the 0. So that's what your first term looks like. This is, okay, so that's your first term. Your next term is going to look like 5, what's 2 to the 4th? Times 16 times x to the 4th times negative 3, right? You understand where that came from? Right? Plus dot, 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 dot.
I'm confused where the 5 comes from.
5 combination 1 is 5. Okay? It's just, you have to kind of either plug that in your calculator or look at Pascal's triangle and figure that out. 5 combination 1. Let's go way back to here. Okay? 5th row, 0th row, 1st row, 2nd row, 3rd row, 4th row, 5th row. 5 combination 0, 5 combination 1. There it is. See that? Isn't that cool? Okay? So going back, going forward, I mean, so then you just simplify. This becomes 32x to the 5th. 5 times 16, I think, is 80 times negative 3. So your second term would look like negative 240x to the 4th power plus dot, 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 dot. Okay? Okay? Tricky, huh?
Easy.
I see. It's fun. I think it's cool.
It's tedious.
Okay. So then,
Wait, what's
cup.
the thing for that one?
What?
17.
Never mind.
Okay, so now let's do one where they say, so something's,
Now.
yes,
So, like in the original
No, we
one,
gave at one.
there's like an R
120,
inside.
no, 130.
this is R,
Oh, 160.
this is R, this is R, this is R, this is R.
So the R changed like from 0 to 5?
Yeah, R goes up and N goes down, right?
Oh, okay.
Okay, R goes up and goes down. Okay, so what if they said this? Two more examples, look, and then I'll be done.
We only have
Okay,
like 8 minutes.
I got it. I got this. X to the eighth. Find. So they'll say find the coefficient of x to the eighth in the expansion of x squared plus 2. And so this is, so x squared plus 2 raised to the 12th power. Okay? So so this is the way you can think about it. I think it's kind of not that bad. Okay? If how do I get x to the eighth if I'm doing something to x squared? What do I need to raise it to? What power do I need?
64.
To the fourth power, right? Because I know that x squared, because I'm doing something in this x squared. If I raise x squared to the 4 power, I'm going to get x to the 8th. See that? Okay? If this is being raised to the 4th power and I have a 12 up here, what is 2 being raised to? What is 2? Very good. 2 is being raised to the 8th. Yes? You understand? Because these two numbers, this and this, always need to add up to n. Okay? Yeah? So
What, 2 numbers?
this and this always add up to this number up here, to 12, right? So 4 plus 8 has to add up to 12, right? Because you're raising this polynomial to the 12th power. Yeah? So if this was 4, this was 8. And the thing that goes in front is what goes down here? 32. No, what's n?
4.
No, what's n?
12.
12. Combination. This always matches this.
Oh, 0.
No.
1.
This.
So now it's 32.
12, 8.
32.
8. Okay. That's what it is. This number down here, okay, always matches this number up here. Okay? This minus this is this. The reason I know this was a 4, because I want the code. So now all you have to do is do the math. 12 combination 8, I'm going to do that on my calculator. Okay? 12 math, PRB, combination 8. Okay? And I'll go to, I shouldn't have put that parentheses in there. Okay? Delete. Okay? So that's 495. So the thing that goes in front is 495. X to the 8th. X to the 8th. 2 to the 8th is 16, 32, 64, 256. Is that right?
256.
256. So the coefficient of this term is going to be 256 times 495, right?
Which is 126,700.
Times 256 equals 12,000.
No,
126. What?
126, 720.
126, 720. 126, 720 x to the 8th. Okay? That's a lot of x to the 8ths, isn't it? Okay?
No.
But if I expanded this out, that's what I would get. You don't want to do that by hand, believe me. Okay?
Oh, I did.
Okay. One more, and then I'm done. Look.
4 minutes.
4 minutes. Okay. So really quick, they say this. We have to change colors. No, they won't say that. But find the fifth term, okay, fifth term of 2x minus 3y to the 10th. 2x minus 3y raised to the 10th power. Could you do that? It's, what's going to go down here? 10, okay? What's going to go down here?
4.
Very good. It's going to be 4 because you start with 0 and you go up, right? So the fifth term is going to be, it's going to have a 4 down here, right? Because you start with 0 and then you go, come on, Will, let me finish my lesson, okay? 10 combination 4, okay? Then I'm going to have 2x raised to what power?
13.
Very good. If this is 4, then these two things have to add up to 10, so that's 6 times negative 3y raised to the 4th, and there you go. And then you just do the math. 10 combination 4, I'm not sure what that is, but let's do it. 10 math, PRB 3, enter, go to, what did I do wrong here? 4, okay. So that's 210. 2 to the 6, what's that? 64 times 64 x to the 6. 3 to the 4th is negative 81, right? Positive 81, thank you. Y to the 4th. And then I just multiply all that stuff together, okay? 210 times 64 times 81 equals come on, stay. 1088640. 1088640, comma, x to the 6th, y to the 4th. The end.
Done.
Done. Hey, we finished. I gotta say, that was great.